The production function is one of the fundamental concepts in economics. It tells you how a certain product is being produced. But you can't get something out of nothing, so to be able to produce, you also need some inputs into the production process. We call these inputs production factors. So the production function tells you just that. How do you use your inputs to produce a unit of output? More formally, it is the mathematical representation of how X, the inputs, relate to Y, the output. How do we present the production function graphically? So here's a figure relating the number of workers to how much they can produce. Every one of the points on the curve represents the relationship between the quantity of inputs, in this case labor, and the quantity of output, in this case tons of grain. For example, point A tells you how much grain can 800 farmers produce. Point B, on the other hand, tells you how much grain can 1,600 farmers produce. So let's assume the output of 800 farmers is 500 tons of grain, and the output of 1,600 farmers is 732 tons of grain. If we divide the product by the number of farmers, we will get an idea about how much, on average, a farmer produces. In our case, if there are 800 farmers in the field, the average product per farmer is 625 kilograms. Notice that with 1,600 farmers in the field, each farmer produces less than that. Each farmer produces 458 kilograms of grain. If you don't trust the numbers, it is time you pause this video now, take a small calculator, and divide the output by the input in each one of those 2 points. The key takeaway from this production function, at least for now, is that as inputs increase, so does the output. But they don't increase proportionally. As inputs double, output less than doubles. We will discuss the reason for this during the live lecture and the seminars later this week. But for now, it is important to note the following. This class of production functions that we see here were typical of the production processes at the onset of the Industrial Revolution. For those production functions, an increase in the amount of labor leads to a decline in the average product of labor. What does this tell you about our Malthusian world? In a Malthusian world, every newborn eventually becomes a farmer. That's the way it is. But increasing the number of farmers leads to a decline in the average amount of product each of them gets out of the land they plow. Then each additional farmer contributes less to the overall income than the previous one, and the average income begins to decline. Thus, as population grows, income declines, and if population declines, average income starts increasing, because there is more land for the average person. There's another relationship we need to consider before we complete the model, the one between income and population. In the model, people have more incentives to have kids when income increases, and less incentive to have kids when income falls. The reason is that as your income rises, you can just sustain more kids. But then we can make two observations in the model. As income rises, people make more kids because they can feed them. But more kids means more farmers soon, which in turn lowers the average product of labor. In turn, the lower average product of labor reduces the average income and reduces the incentives to have kids. So, population growth declines. It turns out that there is an interesting subsistence level of income. This level of income tells you that above this level, people will demand more children because they can sustain them. But below this level, the farm output is not enough to sustain everyone, so the population will have to decline. Once we have the idea of a subsistence level of income, we can move to the concept of Malthusian equilibrium. We will discuss it in the next video. In the next video, we will also introduce a one-time technological progress into the model and see if this is enough to generate an industrial revolution. Thanks for watching.